equals the square root of x squared plus 1. And you can say the inner is x squared. I can say the inner is x squared plus 1. But I have to adjust the outer. The outer will be different, right? So if inner is x squared, then outer is the square root of x plus 1. If inner is it's x squared plus 1, then the outer is the square root of x. So that's why I'm saying, so this will be the square root of x plus 1, and this will be the square root of x. So there is more than one correct answer. But both are acceptable. So if you create f come g, or if you want to use a different notation for this comes this come this will be that. This come this will be that. So you have at least two functions whose function composition will be f of x. Very good question, thank you. Anything else? Anything else? Okay, in that case, we'll continue with 2.8, which is the last section of chapter 2. Okay? 2.8 deals with three different things. Distance formula, midpoint, and the equation of a circle. Distance formula, midpoint, and the equation of the circle. So let's start with the distance formula. We're interested in determining the distance between 2 points. So I'm going to call this point A, I'm going to call this point B, and A will have coordinates x1, comma y1, and of course B will have coordinates very good. And this will be the distance or the length of the line segment between those two. We are going to create a right triangle with a horizontal line passing through A and of course a vertical line passing through B. So these are perpendicular. And I'm going to call this distance the leg 1, and I'm going to call this distance leg 2. Since this is a right triangle, can anyone give us the Pythagorean theorem, but not a squared plus b squared is c squared, because there is no a, no b, no c here. So specific for our case. Can anyone?
Leg 1 squared.
Very good. Leg 1 squared plus leg 2 squared equals the distance squared. This is perfect. Thank you. Now, if I manage to determine these two, then I can write the equation or the formula for the distance. So now let's see. Obviously, this point has coordinate x1, so this must be x1. And this one has coordinate x2, so this must be x2. Is there a way of determining the length of leg 1? Exactly, x2 minus x1. So this is x2 minus x1, which is leg 1. In the same way, we can determine the measurement of leg 2. Can anyone give us the measurement of leg 2, knowing that obviously this is y1 and this is y2? Of course. Perfect. And this will give us the distance formula. I will replace leg 1 by x2 minus x1. And I will replace leg 2 by y2 minus y1 squared equals the distance squared. Now I will take the square root from both sides because I want the distance, not the distance squared. So when we take the square root from both sides, there is one very important item that we cannot forget, which is to write. Correct. Awesome. However, because this is a distance, for this particular case, I will not write plus or minus. I'm not changing the rules on you, but this is a distance, and I cannot have a negative distance. So this will be the square root of x2 minus x1 everything squared plus y2 minus y1 everything squared, and this is what we call the distance formula. Can I simplify this? Please say no. Thank you. We cannot simplify because the square root of a sum cannot be broken into two radicals. Let me give you an example. The square root of 9 plus 4 does not equal the square root of 9 plus the square root of 4. So we cannot break the radical if it's a sum of terms, if the radicand is the sum of terms. Because this is the square root of 13 and this is 3 plus 2. The square root of 13 does not equal 3 plus 2. Perfect. Now, the midpoint is the point right here in the middle of the distance of the line segment AB, I would say, denoted by M, and it divides or bisects, we say, the line segment AB into two equal parts. So we need to remember the coordinates of the midpoint. If I have two numbers and we want to create the average, how do I create the average of two numbers? I add them up and divide by 2. That's exactly how we remember the midpoint formula. It's x1 plus x2 over 2, the average of x values. And what do you think the y coordinate will be? Very good. That's it. Now please invent two ordered pairs so we can determine the midpoint of the line segment and the distance. Any two ordered pairs, but I throw in some negative coordinates in there as well. Negative 2, 3. Good. 3, negative 4. Perfect. So this is my x1, y1, and this is x2, y2. Let's finish up the midpoint quickly because it's the easiest. Please add up the x values. Divided by 2. Perfect. Please add up the y values. Divided by 2. So this is the midpoint. In other words, this is the point that will bisect the line segment between these 2 points in half, or divide in half. Okay, so now let's determine the distance. So the distance, I will always write the formula. I recommend this method, but I accept any. So x2 minus x1, everything squared, plus y2 minus y1, everything squared. And here's a question for you. What type of number will this always be? Always, because it's squared. What type of number will this always be? And if we add two positive numbers, what do we always get? So I will not see on the next test or the final exam something like this for the distance, correct? Not possible, right? Because this is a positive number and I'm adding another positive number to it. So just making sure. Perfect. So now what I would like to do is this. Copy x2 right under x2. Copy x1 right under x1. Copy y2 right under y2. And copy y1 right under y1. Why? I think it's cutting a little bit back on writing, but as I said, I accept any method. So let's do this together. How much is 3 minus negative 2? Let's try again. 3 minus negative 2 is 5. How much is 5 squared? Very good. Plus negative 4 minus 3. Negative 7 squared. Very good. So then the distance is the square root of 74. That's it. Any questions? Okay, let's look at the equation of the circle. I'm going to draw a circle and you can say, no way, that's a circle. It's a shady one. I will agree. I can draw a perfect circle. So let's agree that this is somewhat of a circle. Okay, by convention, the center is denoted or has the coordinates x, h, comma, k. So h is the x coordinate of the center and k is the y coordinate of the center. Okay, so now, can anyone tell us what this is? The line segment that connects the center to any point on the circle, on the circumference. Very good. I'm going to call this point A, and I'm going to have to give it some coordinates like x comma y. And please tell me if you agree with this, that the distance AC is identical with the radius. Would you agree? Is the distance between A and C the same with the radius? Perfect. So now I want this side, and I want to apply the formula that is the distance formula. It's a square root x, yes, x minus h, everything squared, plus, very good, everything squared. Perfect. Okay. We like this, but we'd rather prefer removing the square root. So I will square both sides. The left-hand side becomes perfect. Thank you, Carl. So this is the equation of the circle. With center, what center? Very good, h comma k, and the radius r. There are three types of problems here. From the easiest to the most difficult. Not difficult at all, I think. Types of problems. Number one, I'm going to copy from your book. We are on page, I should have been prepared, sorry about that. On page 332. Let's say problem 35. And the central is given to us as -1, 4, and the radius is given to us as 2. They're asking us to create the equation of the circle whose center is -1, 4, and radius is 2. What do you think we should do? Yes? Yes? Plus? Very good. Everything squared. Awesome. Yes. Yes. Equals? Which is? That's it. This is the equation of the circle with center -1, 4 and radius of 2. Let's say they're also asking us to graph it. If they're asking us to graph the circle, we will start with the center, so which is -1, 1, 2, 3, 4, right here. I will create 4 points, the cardinal points, east, west, north, south. How many units away from the center? 2 indeed. 2 indeed. So 1, 2, 1, 2, 1, 2, 1, 2. 4 points. Connect. Yes, I know it's not perfect. It can never be. So this is the circle with a center at -1, 4, with a radius of 2. Is this a function? No. I still would like you to determine the domain and range. Even relations have domain and range. So what is the domain of this relation or this circle?
-3, 1.
Because this is at -1, it's -3, 1. Perfect. And what about the range?
2 to 6.
2 to 6. Perfect. Very good. So this is type problem 1. Not a problem, right? Okay, and type 2. Let's say problem 45. Same page, in which we have x plus 3, everything squared, plus y minus 2, everything squared, equals 4. Now we are given the equation of the circle, and we are asked, okay, make sure you find the radius and the center. Let's start with the radius. 2. And let's go back to the center. -3, 2. Remember what happened here with -1? This changed into positive. With +4, this stayed negative. Indeed, this is a circle centered at -3, 2 with a radius of 2. Any questions? Last type, type 3. Let's look at problem 55. Same page, with x squared plus y squared minus 10x minus 6y minus 30 equals 0. The question here is this the equation of a circle? And for now, the correct answer is I have no clue. I don't know. But I can say only this. If somehow I rearrange all this to make it look like this, then it's yes, it's a circle. If I cannot manipulate all this somehow to present it in this form, meaning a completed square with x plus a completed square with y equals a positive number. This cannot be 0, because if it's 0, it's just 1 point. There is no radius. If it's a negative number, it cannot be a circle, right? I cannot have a negative radius. I cannot take the square root from a negative number. So this has to be a positive number, positive in the middle, and 2 squares completed, one with x and one with y. Then I'll say, yep, it's a circle. So then what do you think we have to do here? And I already used the word several times to trigger your memory, and I'm going to trigger your memory with one other thing. When we solved quadratic equations, we had 4 methods, and one of them I said, no, it's not for this. It alone cannot do the job. Which method is that? Awesome. It's for this. That's why we studied it. But it alone is useless. It helps somewhat, but it's not a method that solves the quadratic equation. We have to employ something else, right? So then I have to look at these 2 terms, nothing else for now, and identify the number that I have to add to both sides to complete the square with x squared minus 10x. What do you think? Middle coefficient. Middle coefficient? Middle coefficient. What is the middle coefficient? Negative 10. Negative 10 divided by 2. Negative 5 squared. That's it. And remember, we have to add it to both sides. Now, these three terms are here in this perfect square, which is?
X minus 5 squared.
Thank you very much. Let's look at y squared and y. Middle coefficient. Divide that by 2. Square negative 3. That's it. Just remember to add to both sides. So now I have plus, and in here I have these three terms. 1, 2, 3. What three terms? Yes? It cannot be plus if this middle term is negative. Minus. Perfect. Exactly. So now let's see what is not accounted for yet. This is not accounted for. We haven't used it. This we have not used, and this we have not used. So on this side, how much is 25 plus 9? 34. But I have to bring a 30. Exactly. So now we can answer the question. Is this the equation of a circle? Yes, because we were able to arrange it like this. And now we are able to identify the center, and we are able to identify the radius. Yes? Very good. That's it. But this was possible only because we knew how to complete the square. Otherwise, we would have not been able to. Sure. Any questions on this one before we choose another?
If the
Yes?
constant on the right side of this equation isn't a perfect square, does it still work?
Yes.
Okay.
Yes. So for example, I could have x minus 5 squared plus y minus 3 squared equals 7. In this case, the radius would have been the square root of 7.
Okay.
Absolutely, yes. Very good question. Thank you. Yes, right now. Any questions on this? Okay, so let's take a look. So let's say 58. It's x squared plus y squared plus 12x minus 6y minus 4 equals 0. Is this the equation of a circle? The answer is I have no clue. I don't know. But if I manage to present it like this, then it's a circle. If I can't, then it's not a circle. If I get a minus in here, or if I get 0 here, or -5 on the other side, then it's not a circle. If I don't get the squares, it's not a circle. Okay, so then I have to complete the square with x. What do I do? Good. So what do I need to add to both sides? Very good. Awesome. It's 12 divided by 2, which is 6, and I square 6, and I get 36.
Now, how do you know how to, like, how do you know if you have to use that? Because I never got that part when we used it the last time. I never got that.
How do I know that I have to complete the square?
Mm-hmm.
That's the equation of a circle. If I don't complete the squares, and I cannot complete squares, it's not the equation of a circle.
Okay.
Yeah, only because that's the equation of a circle. And I'm asked, I'm given a bunch of things and terms equals 0. Is this the equation of a circle? And I have to say only if I manage to complete the square. If I can't complete the square, then it's
Okay.
not an equation of a circle.
Thank you.
My pleasure. So then this squared, these three terms are here. Now you understand almost every class, every meeting we had, we used this first day special product almost every day. That's why I insisted from the very first day to remember that. So what do we have in here? Because this is positive 12. Yes, very good. So now we have to complete the square for y. So this and this. What do we need to add to both sides? Very good. So then we have plus. We have to have plus. And something squared with y. Careful. If this is minus, we cannot put plus. Very good. Awesome. So now let's see what we have not used. We have not used this number. We have not used this number. And we have not used this number yet. So what do we get on the right-hand side? Yes, but I have to write 49, and the radius will be 7. And what is the center of this this circle? Negative 6, 3. Perfect. Do we understand this? Is this better? We feel better about it? Okay, perfect. I'm hoping that between now and Thursday you'll want to work on some of these problems and bring more questions to class. Okay, finally we can say we finished this long chapter, chapter 2. So we can start chapter 3. Chapter 3 is much shorter. However, most of it is new to you. So I would like you to please, if you can, I know it's a long class, but I'm hoping that you can pay attention. Okay, so chapter 3 deals with polynomials and rational functions. Polynomials and rational functions. So in short, it has number 1, linear, which we will not discuss again. It's not part of the polynomial functions. It's not part of this chapter anymore. We know this function inside out. Number 2, quadratic. You can say, I know this function inside out as well. True, but we still have some details to work on. Number 3, third, fourth, fifth, sixth degree polynomial functions. 4, rational functions. And the last item is polynomial and rational inequalities. Okay. So let's start with quadratic. This is section 3.1. Quadratic functions. And you can say again, didn't we play with them enough in transformations and so on and so forth? Yes, we did. But we're going to look at applications here, and we're going to graph this function exact, not like this using transformations. Okay. So a quadratic function can be given to us in this form, which we have seen a lot, or in this form, which we have seen in transformations. This point, h comma k, I will come back and explain what it is. It's not connected to the equation of the circle. It happens that we use the same notation, but it has nothing to do with the circle. It's a different point. I will discuss it in a minute or two. So first I would like to pick a function like this and graph it. And then we'll look at this one and we'll come back to this point. Okay, so let's say f of x equals negative x squared plus 8x minus 8. Obviously, A is perfect, B is perfect, and C is correct. So it's this form. What's the difference between these two? Can I go back and forth from one to the other? Yes. So what do you think this is called? Or what does it have? We just used it a minute ago. What is this? A completed square. And this one doesn't. So if I complete the square here, I get this. If I expand this, I get that. So it's, of course, these are different numbers. They're not A, B, and C. Okay, so here we're asked to graph. In order to fully understand the graph of this function, we have to go through 8 steps. Step 1, domain. But we know that all polynomial functions are friendly functions. If it's linear, if it's quadratic, cubic, it doesn't matter. So what do we know about that? Domain is all your numbers. Perfect, thank you. Number 2, shape. And you can say, wait a minute, you haven't even graphed it. How do I know the shape? Very easy. So the parabola, it's a parabola, by the way. The graph of a quadratic function is called a parabola. We graphed it so many times, I don't think I mentioned the name. So the graph is a parabola, either opening upwards or opening downwards, correct? So if it opens up, then this point is a minimum. If it opens down, this point is very good. So both points, it doesn't matter if it's a minimum or a maximum, both of them are called vertex or vertices, but singular, vertex. If a function, a parabola has a minimum, if you remember this is x squared, what is the leading coefficient of x squared? 1. So a is a positive number when the parabola has a minimum. And a, the leading coefficient, is a negative number when the parabola has a maximum. Since I know that a, the leading coefficient in this case is, and remember everything has to be in descending order, so I don't identify something that I shouldn't, right? Since the leading coefficient is -1, are we talking about a minimum situation or a maximum situation?
Max.
Max, very good. So remember x squared, positive leading coefficient, has a minimum. Because we graphed that many times in 2.5. Okay, perfect. Number 3 is what it's called the vertex. The vertex is this point, and of course, like any point, has 2 coordinates, has x and y. I do have to find x first. How do I determine the x-coordinate of the vertex? Very simple if you want to go back to the quadratic formula. This is the x-coordinate of the vertex. Let's find it. Negative b over 2a. Negative. How much is b? Perfect. How much is 2 times a? And there are 2 negatives in this problem, in this calculation, so the answer is 3. So the vertex has 3 as the x-coordinate. Now the question is, how do I find the y-coordinate?
Solve the equation using the x-coordinate of the vertex.
Exactly. Plug it in. So this y-coordinate must be f of 3. If I determine x, I have to determine that if I pick x, like in this case we determine it as being 3, the y-coordinate must be f of 3. Are you with me? Is that clear, everyone? Okay, so f of 3, I have to go back and plug it in. Negative 3 squared plus 6 times 3 minus 8. Please be very careful because you are not squaring negative 3. You're squaring 3. You're squaring 3 and then you multiply the answer by negative 1. So do not say positive 9. So it's 3 squared, which is 9, times negative 1, which is negative 9. 6 times 3 is 18, and minus 8. Negative 17 plus 18 is 1. So the coordinates of the vertex are 3, 1. Any questions? Are we okay so far? Perfect. Next step. For X-intercepts, very important now, comma, if they exist. Okay? What does that mean? Let's talk about the possible situations first before we continue. Does this parabola have a max or a min?
Max.
Very good. So there are 3 options. Here's one option. How many x-intercepts? None. Very good. How many x-intercepts? Yes, it's still 2, but they are both the same. And we can say 1. It's 1. But they are 2 and both the same, and you'll see what happens in the section 3.2. And here's the other option. How many x-intercepts? 2. Distinct. Here, 2 the same, or you can say 1. I accept that. Here, no real solutions, and here, 2 real solutions. Now, we did discuss what it's called a discriminant. Anyone remembers what the discriminant was equals to?
Is that the radicand?
The quantity, yes, the radicand. Very good. Indeed. So this is a discriminant. This is the quantity under the square root in the quadratic formula. Can anyone tell us what type of number is b squared minus 4ac in this situation, then in this situation, and then in this situation? If the solutions don't exist, what could b squared minus 4ac be? Let me present the quadratic formula. Maybe it's easier to look at. So negative b plus or minus the square root of b squared minus 4ac over 2a.
Oh, less than 0.
Of course, less than 0. Why less than 0? Because this will be a negative number, and the square root of a negative number will give us what type of solutions? Imaginary. Yes, not real. So that's a situation. Okay, what is b squared minus 4ac when there is only 1? I should say 2, but they are the same. When the discriminant is? If I'm getting only one solution, then I'm only getting negative b over 2a, and this is the coordinate. These are the coordinates of the vertex. So what has to happen here if I'm only getting one solution? If I'm only getting this, what should this be? Definitely
0.
right. Must be 0. Must be 0. If I only get one solution. And what about here? I got negative, I got 0. What could this be?
Positive above 0.
Very good. If it's positive, then I will take the square root of 4 and get 2 distinct solutions. So please keep that in mind. Okay, so now I'm coming back. This is the vertex. And I want an analysis from you. Is this situation, or this situation? Number 1, number 2, or number 3? Where do I look to identify? This is the key. This number is the key. This number tells us whether there are x-intercepts or not. So is it number 1, number 2, or number 3? Exactly. Because the maximum value is not a negative number. It's not 0, but a positive number. So it must be number 3. So therefore, do the x-intercepts exist or not? because I don't want to waste my time. If they don't exist, I'll say move on to the y-intercept. They do exist. Very good. It's the third case. Very good. So then how do I determine the x-intercepts? For any function. I said, for any function, the x-intercepts. I said, what? I said the y equal to 0, right? It's the x-axis. So let's set y equal to 0 and find the x-intercepts. Okay, so y equals 0. Y is the function. Negative x squared plus 6x minus 8 equals 0. Again, I know I'm repeating myself a ton. So what type of equation is this? Of course, it has something that I refuse to handle. I will get rid of, which is, yes, you can solve it like that. I won't. So x squared minus 6x plus 8 equals 0. I have 4 methods of solving quadratic equations. Which one will I choose? Completing the square? Of course not, ever. Okay, can I take the square root? No. So I will always attempt to factor. So is it factorable? Good. So this is x minus 4 and x minus 2. Very good. So there are 2 options. And this is the principle of zero product that we are using right now. So we get x equals and x equals 2. So what are the ordered pairs that we just determined as x-intercepts? Awesome. Perfect. Awesome. Very good. Next step in line is number 5. What do you think? After x-intercepts. Of course. And this will always exist. Always. How do I determine it? I said what? X. Very good. So I need f of 0. That's not a problem. 0, 0. Very good. Which is the ordered pair that we just determined? Awesome. Thank you. Okay, 6, 7, and 8. 6 and 7 are just words. Okay, let's go back. Any parabola, and I'm not talking about odd or even, any parabola has an axis of symmetry. The vertical line passing through the vertex. Yes. So I will write axis of symmetry. X equals. Very good. Awesome. Thank you. Since this function has a max or a min. Very good. I will say the max value is of the function is exactly is 1, or y equals 1. Perfect. And the last step, I want the range. And you could say, range? You haven't even graphed it. Oh, we already know the graph. What is the range of this function before we even graph it? Negative infinity to the maximum value is 1. Negative infinity to 1. Good. So now let's graph. Any questions? We always start by graphing the vertex. And the vertex is 1, 3, no, 3, 1, right here. We draw the axis of symmetry, but it's not a solid line. It will only help us keep the graph in shape. That's the only purpose. Then I plot the x-intercepts for 0, 2, 0, 2, 0, 4, 0. Notice that they have to be at the same distance from the axis of symmetry. If by mistake I get 2 and 5, I know something is wrong. They have to be symmetric. And then I plot 0, negative 8, 3, 4, 5, 6, 7, 8. And I try to graph and not make it too acute at the vertex, if possible. And keep it as symmetric as possible. Of course, mine is not symmetric, as you can see. I have to make some adjustments here. It's still not perfect. But anyway, this is the f of x, negative x squared plus 6x minus 8. Any questions? Yes, of course. Any questions on this problem? Can I move to the other form, or you still want to work on this form? I'm fine with either way. Okay, very good. So let's take a look. We are on page, let me choose now from your book. And we are on page 360. Let's look at problem 27 on 360. We are given f of x, which is x squared minus 2x minus 3. Very good. 8 steps. Number 1, we're asked the same thing. We're asked to graph. Number 1 is domain. Right. No problems, no square root, no denominators. Perfect. Number 2, shape. Max or min? Very good, because the leading coefficient is 1. Number 3, the vertex. Can anyone give us negative b over 2a? Negative 2 over? Very good. And the answer is?
Is it like negative and negative 2?
There are 2 negatives. 1. Is that okay? Good. How do I determine the y-coordinate of the vertex? Very good. Indeed. F of 1. So 1 minus 2 minus 3. Agreed? So the vertex is 1, negative 4. Number 4, X-intercepts. But I don't want to waste my time. It has a minimum. Does it stay above the x-axis, which means no solutions, no x-intercepts? Does it touch the x-axis, or it goes below the x-axis? If it goes below the x-axis, we find x-intercepts. If it stays above the x-axis, no x-intercepts. If it is turning on the x-axis, then that is the vertex as well. Do they exist or not? They do, because this is the indication. The minimum is not positive, and it's not 0. It's negative. So the x-intercepts exist. So I will spend the time to find them. Good. How? What do I have to write? How do we find the x-intercepts for any function?
So that's y.
Just y. And then for the y-intercept, the x. Correct. Very good. So x squared minus 2x minus 3 equals 0. It's quadratic. I hope I can factor quickly. Can I factor?
X minus 3 plus 1.
Very good. So we have 2 options for x. X equals, very good, 3 and negative 1. So then we have two ordered pairs that represent the x-intercepts.
3, 0, -1, 0.
Very good. Step 5, y-intercept. How do I get the y-intercept? X equal to 0. 0, 0, negative 3. So f of 0 equals negative 3, which means perfect. 6, 7, and 8 are just words. Axis of symmetry, please. Very good. X equals 1. Perfect. Minimum or maximum?
Minimum.
Very good. Mean value of this function is perfect. Range now, although we haven't even graphed it, and we know the range. Very good. See, we really split hairs in this situation. We know everything about this function. There is no secret whatsoever. Okay, ready? We start with the, very good. So 1, negative 4. Right here. We draw the axis of symmetry, not as a solid line. It's only supposed to help us keep the graph in shape, symmetric. Okay, so that's the vertex. Then we have 3, 1, 2, 3, 3, 0, and negative 1, 0. Make sure that these two are exactly 2 units away from the axis of symmetry, and they are. And then we have the y-intercept, which is 0, negative 3. And now we can graph the function. Again, I don't have a perfect graph for you, sorry. So this is the graph of f of x, which is x squared minus 2x minus 3. Feeling better about it? Perfect. My pleasure. Okay, so finally let's look at the other form. Let's say 20 on page 360. And then I'd like to look at word problems. So this is x minus 3, f of x equals x minus 3 squared plus 2.